Hi everyone, and welcome back to the wonderful world of prob and stats. Today we'll discuss geometric and negative binomial distributions. A negative binomial variable is characterized by the following features. Identical random experiments must be taking place. The result of each experiment will either lead to a success or to a failure. At every trial, the probability of observing a success remains constant and equal to p. Variable x actually counts the total number of trials that led to the rth success. In order to label a variable that is obeying a negative binomial distribution, we're going to write that x follows a negative binomial, r successes to be obtained, and probability p of a success at every trial. Exceptionally, when a negative binomial is meant to count trials until a first success occurs, then the variable is called geometric. In other words, a negative binomial with one success to be obtained is also a geometric. Here are examples of negative binomial variables. Suppose you are throwing a coin until heads has been observed 5 times. Variable x, defined as being the number of coin flips to get those 5 successes, obeys a negative binomial where 5 successes are to be obtained, and 50% is the chance of a success at every trial. Suppose you toss 2 dice simultaneously until finally a sum of 5 occurs. Then y, the number of dice tosses until that sum of 5 occurs, is a negative binomial where one success has to be obtained, and 1/9 would be the probability that a sum of 5 actually happens. Because there's only one success to be obtained, we could also consider this a geometric of probability 1/9. The expected value, variance, and standard deviation for negative binomial variables obeys certain formulas. The expected value is r over p, in other words, r successes over the probability of a success. The variance, r times 1 minus p over p squared. Standard deviation is the root of the variance. We will not demonstrate these formulas, but we will use them in the appropriate context. If probabilities are to be calculated in a negative binomial situation, then the probability function is given by the combinations of k minus 1, from which r minus 1 are chosen. That represents essentially the r minus 1 first successes having to take place in the k minus 1 first trials. That will also ensure that the rth success occurs on the kth trial specifically. P to the r is the probability of obtaining those r successes, and 1 minus p, k to the power k minus r, are the k minus r failures that must be observed along the way. As always, we can use Excel to calculate the probability for specific values of a negative binomial distribution. Here I have a French version of Excel, Loi Binomial Négative. You probably have a negative binom dist function in your Excel settings. As an example, let's assume 30% of current Marianopolis students graduated from a public high school. Suppose Marianopolis students were selected randomly and with replacement from a list provided by the registrar's office until we observed 6 students who have graduated from public high schools. Now let x represent the number of students who are interviewed until 6 of them declare graduating from a public high school. Then x is definitely random, because perhaps the first 6 that we interview do actually come from public high schools, or it may take 100 interviews before this occurs. Does x obey a negative binomial distribution? Well, in order to answer this, we have to verify that the characteristics of a negative binomial are observed. The experiments are identical. We're selecting students from the same population. Each interview will lead to a success or to a failure, that is, coming from a public high school or not. At every trial, there is a 30% chance of a success since names are replaced after being selected. And the variable of interest here is the count of students leading to the 6th person saying he or she comes from a public high school. Labeling variable x in this situation would be to say that x follows a negative binomial where 6 successes have to be obtained, 0.3 chance of a success at every trial. Expected value, standard deviation of x, can be calculated by using the formulas we stated earlier. So r over p would be 20 in this case. So we would expect 20 students to have to be interviewed in order to find a 6th respondent coming from a high school that is public. The variance, r times 1 minus p over p squared, and the standard deviation tells us that a deviation of 6.8 interviews is to be expected. What is the probability that the 6th student who graduated from a public high school occurs exactly on the 20th interview? We're going to use our probability formula in order to calculate this specific probability, which comes out to 5.75%. Or we can use our Excel functions to calculate the same probability. What is the probability that the 6th student who has graduated from a public high school occurs no later than on the 20th interview? So this time we're looking for p being less or equal to 20. 58.4% is the result of this specific event, would be the sum of the probabilities for x equaling 0 all the way to 20. Once again, Excel functions will allow you to accumulate probabilities up to 20 in this case. I think that's it for today, and I hope that you enjoyed it.